Welcome to Careless Coder, and today I will be sharing my tips and tricks to speed up your KiCad, schematic and PCB workflow. Motherfucker! So KiCad is a free and open source PCB and schematic drawing application. And it's actually really good. But when you come from Eagle or OrCAD, you will notice that there are some really quirky things that trip you up initially, and that your workflow feels really sluggish and slow. In this episode I will show you how I progressed to an intermediate speed, and I will show you all the little pitfalls that you need to avoid coming from OrCAD or Eagle. So let's jump in and have some fun with KiCad. So here are some tips to really create schematics and PCBs fast in KiCad. First, we create a new project. And I want to put this under my KiCad folder. Where is my KiCad folder? There. New folder. ADC. We're going to make a R2 ladder ADC. And let's call this also ADC. So there we go. Let's first create the schematic. Right. First we need to put down a component, that's this op-amp symbol. And then you click where you want it to be put down and it will load the first time all the references. We're going to make a ADC, an AD converter, analog to digital converter, for the parallel port, which I am creating now for another video. I actually created this schematic before and its PCB is on the way. So I click it here and now we need to mirror it. You can use X to mirror it over the X-axis, as you can see. And I want the 1 on top and Y to mirror it over the Y-axis. These keyboard shortcuts are very important. Move, hover on top of it, click M for move and you can move it. We're going to add a resistor. And we're going to use the European format, the nice rectangular format, not the American squiggly lines. Let's align it here. And since we're going to create an R2 network, that means that R is a certain value and R2 is twice that certain value. So let's, for these R2s, set a value, press V for value of 20k, so the other is 10k. I'm not yet bothered with the reference, because we're going to let that auto-generate by KiCad. That's kind of cool. Now I want to copy this. Let's move this in the resistor and let's move this there because we're going to have a couple right next to each other, so it's more legible. Click, hover on the resistor or component, click C for copy. Boom, C, boom, C, boom. Let's block everything. Copy block, that's Apple C in my case. Paste. And this continues on 6. Okay, one resistor too many. Well, technically not too many. Let's delete that. Where is it? 1, 2, 3, 4, 5, 6, 7. No, it is correct. Yes, it is correct. I miscounted. So let's drag the wires in. Click on the wire. You could also use a bus, but that's a bit more advanced. We'll get that in a different video if there is enough enthusiasm for these videos. Luckily we only have 8 bits on a parallel port. So there we go. Now we need to add more resistors. So click there, click where I want it. I want an R, yes. And the value, V for value, this is 10k. And I again do the C to copy, and let's give it a bit more real estate. M for move, M for move, M for move, C, 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 1, 1, 2, 3, 4, 5. I could have copied the whole block. 6, 7, 8, and the top one that goes to ground is 9. Yeah, that's correct. Let's link these up. See how quick of a workflow KiCad can have. Initially I was so accustomed when I started working on PCBs with OrCAD, and that was back in the 90s. I was really fast with OrCAD. Then Eagle came and I was so frustrated with Eagle because it didn't have that speedy workflow. It does, but you need to learn it. And then I switched to this last year and I was like, oh my god, here we go again. But yeah, if you put the effort in it for just a couple of hours, then you have that same workflow back on your fingertips. I will explain how this ladder ADC works in one of the DOS-Sember episodes, where we actually create this to create parallel port audio. This goes to ground, and I know that 20 is a ground pin. I did a lot of wiring on DB25s for parallel and serial, so I know these port numbers by heart. We're going to create a power pin. Let's click on the power, and I want to create a GND. Power GND. Ground. There we go. That's a nice ground symbol. And now you would think that this is sufficient, but it's not. Because the electrical rule check in KiCad doesn't know that this comes off board, that it isn't part of the schematic. So we also need to tag a GND and a VCC. Let's also add a VCC just for illustration. I'm going to remove this. Let's first add a VCC as well. VCC. You should something like that. This is for illustration purposes, the VCC. We're going to remove that later on. And again, we're going to add a power, but it's called a power flag. And this will tell KiCad that the net VCC is externally powered. And this is a bit of a weird one. Something that you don't do in Eagle and OrCAD. And again, when you have put down components, you will have the last used list on top. RR for rotate, or R for rotate, but I needed to rotate twice, so RR. Boom. I need a cap here. Let's add a capacitor. CP, capacitor with polarity. Those things you will remember when you do it a lot. I want that there. There we go. Then I want to add a jack, a 3mm jack with 3 poles. Yes. I want to mirror it over the Y, and I want to mirror it over the X. That way we have the S below. Because this is a mono signal, I will put them on the left and the right. And let's again add a ground. We could also run a wire, of course, to this ground, but I like to keep my schematics as clean as possible. Boom, that is it. Now let me illustrate something. First I need some more ground pins. 23 is a ground pin as well. 24 and 25, so there we go. Now let me illustrate something very cool. We didn't set all the references yet. We set the values. No, we did not. I need the value here. Value 0.1 microfarads. And let's also, for good practice, add a cap over here to the noise. A small one. Boop. And also wire that to the ground. And let's give this, press V for value, and let's... It doesn't really matter. Let's do a 0.1 microfarad. Okay. So we didn't set any of these references. Let's set the references in one go. Tools. Annotate schematic. Use entire schematic. Keep existing annotation. So if you already have typed R1 here, then fine, annotate. And let's do an electrical rules check. Now you see, on purpose I didn't connect this one. Ooh, there's a lot of passive flags. That is because these are not connected. Now you can ignore these warnings, but we don't like ignoring warnings, so we annotate these with not connected. That's the cross. So there we go. Let's run the ladybug again, the electrical rule check. And let's click on run, on the location. And it will jump to that location where it is off. Let's do this. Boom. And you see, oh, that's not connected. Cool. Let's run that through there. Boom. Now we need to set footprints. And I need to remind me to remove this later on, but this is for an example that I will show you after we've done the footprints. Something very tricky with KiCad. So let's add some footprints. You can select all the resistors in one go by holding the shift and then the select, because generally you have the same type, and I have an 0805 hand solder. The hand solder pad has a little more pad for you to put down the soldering iron to heat it up. The audio jack, I always use the CUI, and I didn't double click. You need to double click in order to get that. The DB25, I'm going to make an edge mount, so we wedge the PCB in between these and solder them. Edge mount, that's the one. The 0.1 microfarad, let's make that a through hole and a radial 4 millimeters with a 2 millimeter pad. That's generally normal. And let's make this a nice SMD one, an electrolytical. It doesn't really matter. What are we going to use? A 1206, that's a nice big package that you can solder. But I do have this one, the 0805. Let's use that. It doesn't really matter, it's for illustration purposes. So now that we're done, we have set the footprints. We can actually generate a netlist that will tell the board what the net layout is. And let's go to the board. Let's import this with this nice little big arrow. 0 warnings, update PCB. Cool. So that looks nice. We're now basically ready to wire up the PCB. We will be doing that in a moment, but I want to show you something very nasty and sneaky from KiCad concerning these VCC and grounds. Let's assume for a moment that we're going to add a 7400 NAND gate to drive an LED. So let's invert this, so we make this an inverter. So when that is low, it goes high. So let's sync it to ground. Let's get a resistor. We already have that here and recently used. Let's use that then. That goes so much quicker. We wire this up. And we set this to VCC. This is a very typical buffered circuit. Let's run the auto annotate again. Annotate schematic. Boom. And let's add a footprint for these two. It doesn't really matter for now. Let's just select something quick. We're going to remove this anyways. So we now have a package with a nice NAND gate. Let's go and generate the netlist again because we changed the net. And let's go to the board and import the board again. You will see something very scary. And this puzzled me the first time that I worked with this. Let's click off and let's M for move. If you have any previous experience with these sort of electronics, the TTLs, you know that these are the ground and VCC, and you see they are not connected. Even though we did annotate the board with a VCC and a power flag and a GND and a power flag. This should be enough. In KiCad it is not. In Eagle and OrCAD this works. What we need to do is we need to add a new component. And as you can see, the 7400 has a drop down. And unit E has the power. So let's put that there and let's add... this is the GND. Let's add the GND there and let's add a VCC there. Oh. There we go. And since the VCC has the power flag and the GND is the power flag, this should now work. Let's generate a new netlist because we changed the net layout. Replace. Oh, we need to not automatically annotate it. I will do a press U for annotation. And if I do an auto annotate, it would have called this U2E. But it's the U1. And let's import it again. Update PCB, yes. And now when I click off and move, we will see that the GND and the VCC are connected. So this is a little sneaky thing of KiCad that you need to be aware of. Now let's going to move this because we're not going to use that. Delete. And this is how quickly you can actually draw in KiCad when you have these shortcuts down. Let's run this again, that's good. Let's run the net again. Generate netlist, okay. Right, let's go and make the PCB now. Let's import it again. Update. Close, okay. Let's press M for move. Hover over the component and move. So yeah. Let's set the grid to 2.5 mil. That is a European standard size. Let's put it there. Here you can set your grid size, and for the components I will generally put it on 0.25. So let's move my M1 in, click on it, M for move, and let's see how it's wired this way. R2, that's R2, move, rotate, R for rotate, it's the same key combinations. And I'm rotating so that, of course, the pad is nice and straight ahead. And I don't need to run the wire from the rear, that is not convenient. That is where the 4 went, okay, fine. If that is where you put it. Where's the 5? There's the 5. Move. I put it up here. It's closest to that pad. Okay. Move. Try to keep a bit of distance if you're going to hand solder, so that you have some space in between those pads. Assuming that you're doing SMD. If you're doing THT through hole, then it doesn't really matter. $17. We got some real estate, so I have some space here, so that I do not mix up these two. R, M for move. Let's put that one here. Move, and the cap, we can rotate that like so. And put it over there. Right. So we have the PCB edge. We now need to draw the PCB, or the PCB cut. So we go to the edge cuts layer, and we click the nice little drawing symbols. You can use these three, but we're going to use any straight solution. I will set it back to 2.5 millimeters, and I was hoping I would line up there. Let's then select everything and move it onto the grid, because this is the PCB edge, like it says, and I want it on that grid line, so that the PCB is actually, well, that's closer to 1 millimeter. Move. So that the PCB is on that line. Now I can actually put my edge cut on that line. There we go. Yes. Click. Click. We're going to keep it simple with straight lines. Click. Click. A little overshoot is not bad practice. And we're back. So now we have a nice little outline and laid out board. We can watch what it looks like in 3D. So view 3D viewer, or option 3. And we see that some of these annotations are a bit overlapping, so that's not really that nice. Even though it wouldn't be a problem for the manufacturer, but it's just not something that we want to see. So let's move those. So that's, I'm not needing an edge cut. I need to have the move tool. Click on the move tool, hover M, and I need to reference. Put the references here. For reference, move, M for move. Reference R3, M, move. Not liking this. I'm actually going to drag something out. So we're still the move tool. And then right click and say move exactly. Move. Just add a bit more space. Now we need to do the edge cuts again, or extend them. So. And we just have a bit more space to put the annotations. Move. Rotate. Move. And I'm actually going to move these back just a tiny bit. Select them all. M. Oh. And this one as well. I need to select them all. Come on. Why doesn't it select them all? M to move. Yes, and then I can move this one in the middle. Now we should have something nice, view 3D, that we can actually read. Yes. That is proper, that is nice. Yeah. Okay, let's wire this up. This is going to be very quick because it's a simple schematic. Let's select the layer that we want. We have the copper layer and the background copper layer. So let's start with the 4 and just drag these lines out. Oh, that one needs to be rotated, so let's rotate and this one too. I missed a couple. Rotate. Now of course I need to, that is something that is weird. I would love to see that these are not connected. But yeah, it is what it is. It's a free package, so who am I to complain? Ah! I want to rotate this as well. R, let's do that. R. And now we can do something very cool, because as you can see, we start on the top layer here, but we need to go to the bottom layer. Now the quickest way is to drag out your line and click V for via, and then click, and then you can move, and it automatically switches to the background layer. That is very convenient. Let's immediately connect all these ground wires. There we go, we're done with that. And there should be a ground here as well. Let's click there, let's press V for via. Click down, then it activates the via and it will allow you to drag it out. And boom, there we go. And this connects to there, and that connects to there, and that connects to there and there. This is the reason why I picked this schematic, because I don't need a lot of time thinking how to connect this up. So, there we go. Boom. And this needs to go to ground as well. We can run it around. Now, you see these little edges here. And as soon as you're on that edge, the electrical rule check is not going to allow that. I think this is just borderline allowed. Let's see if it is or if it's not. Otherwise we reroute it. But it's really on that line here, and that shouldn't happen. Click the electrical rule check and it's completely satisfied with it. But now we want to have a couple of mounting holes here. So let's click on the footprint. Let's click there and type mounting hole, and let's have a 2mm mounting hole here for a case. And let's have it here as well. Does it fit there? Or do I need to reroute the hole? No, it fits there. It doesn't touch it. Ref. 2mm. Let's change that. And this also 2mm. And let's move this so that it is legible. There we go. Let's have a look at our PCB View 3D viewer. That looks nice, so we can have a case with 2 little screws in there. I want the J1 to be moved down there because it's outside of the box, the board. Not the box, the board. M for move. Let's rotate this. And let's also add some text on the silk screen, F silk screen. T, I want some text here to indicate that this is pin 1. Let's then move this. I don't like having vias on text. Via, move, move. Let's move that via over there. Let's delete. Oh, well, you know what? We're going to delete this. Delete. Delete. We just rerun it. Track. Delete. Track. Delete. Let's just rerun this. Click. I need a line. Click. And let's put the via there. V for via, click down, and let's connect it. So. And it should still be satisfied. It is. Actually, this could be a nicer route like so, but for intents and purposes, for demonstration, this is nice enough. So there you have it. Everything is nice and clean, legible. We could technically move the R4 up just a little, but these are just very minute little things. But yeah, when you're anal like me, it trips my OCD. I cannot see that and unsee it, sorry. So that's better. Yeah, that looks nice. But now we want a ground plane. Because all nice PCBs have ground planes. And there is this lovely feature here. That's this one. Click. And let's go back to the 1mm. Not going all the way to the border. So we click. I want the front. And I want it to be a ground plane. Just run it. Ignore this this warning. For now it's a warning. If you want to move, hold down the middle mouse button and drag. Let's zoom in. I need to and there we go. So that's one ground plane. Let's do another one for the bottom. Click, bottom, and we also want that to be a ground plane. And we run a similar route. Whatever you want. I'm a bit off, but for intents and purposes, demonstration, it's nice enough. It will work, even electronically. And zoom in to finalize it. There we go. So now when we view it and we render it, you will see here that there is a nice ground plane that it generates for you. So there you go. Now we need to actually send this off to a PCB manufacturer. How do we do this? Very simple. Click on the plotter symbol here. These are the layers that you need to export in Gerber files. I got them from the PCBWay website. And this also works on JLCPCB. So let's generate a new folder and call it Gerber. Always put your Gerber folder under your project folder, otherwise you don't know what it is. Yes, and I should have printed plot. Click plot, there we go. So now we have those. And the drill files, we also need those in the same directory. Okay, yes, and generate drill files. There we go. Boom. Easy as apple pie. So now you go into that folder and you zip them. I almost forgot where I kept my stuff. Hey, we didn't generate... I generated them over here, the bugger. You see that? That's not what we wanted them to be. Move to bin, let's do it again. Output. Gerber files, yes, plot. I must have misclicked somewhere. And there we go. Select all of them, compress them, rename them ADC SMT version 1.0. And then you go to your favorite website. I like JLCPCB because they are cheaper and the quality is, well, if identical, if not just mildly less good than PCBWay, but look at that, it's really cheap. And they deliver just as quickly. Come on, process them. I think China has a power outage again. There we go. And look at that, so it's generated, it will cost you €1.73. And then you get 5 pieces. It's unbelievable how they can make it for this. And it's nice. It looks like how we created it. So there you have it. We created a schematic and PCB in literally 40 minutes. And that is pretty fast actually. And the KiCad shortcuts with the C, the R, the M, the V, the U, that really helps to speed up your workflow. The auto annotate was something that I only found out a couple of weeks ago, and it's like, wow, this speeds up my workflow incredibly. Just like the V for the vias and then automatically route to the next layer, that is so clever. And it made me appreciate KiCad even more. I already appreciated it because it doesn't cost a dime, but now it's like, yeah, it's actually working. So thank you for the guys who created KiCad. I love it. I will use it a lot. I already did a lot with it. And when you're into the whole retro stuff and you need to create little mods, etc., try out KiCad. I hope you learned something and see you in the next one.